In this video, we are going to provide an overview of our treatment structure sizing calculator. The purpose of this calculator is to provide a means for users to accurately design hydrodynamic separators to meet target performance goals. The test protocol utilized in this calculator was developed by the University of Minnesota's St. Anthony Falls Laboratory as a means for MS4s to report measurable goals under the National Pollutant Discharge Elimination System Phase 2 regulations. The calculator is built in a spreadsheet for transparency and ease of use and consists of multiple tabs. The Input and Performance Results tab is the user interface for the calculator, including areas to enter project-specific and location-specific design data. All user inputs and calculator outputs are located on this tab, and the tab is designed to easily print or export to PDF for ease of inclusion in design submittals and for ease of design review. Darker input cells contain drop-down lists, with the hydrology location and particle size distribution lists also containing an option to input custom data. Once the design data is entered, the structure dimensions are simply adjusted until the target removal efficiency is met. Many calculators are also included on this tab should the user desire additional design data for time of concentration, water level, or pollutant loading. Inputs for custom precipitation and particle size distributions can also be entered on this tab. The About tab includes information regarding the background, purpose, and development of the laboratory test protocol utilized in this calculator, as well as an overview of the calculator methodology. The graphs included in this tab help to illustrate the accuracy of the test protocol and this calculator. The first graph shows the removal efficiency test results for sump manholes with varying dimensions as well as wide variations in sediment sizes and flow rates. Considering the extensive range of test inputs, the degree to which the results collapse to a well-defined trend and performance function exhibits the impressive accuracy of the test protocol. Similar testing is also performed at much higher flow rates to determine device-specific performance for scour and washout of previously captured pollutants, which is significant for some devices. Because this is the only methodology that incorporates the effects of scour and washout on a device's overall performance, it is the only methodology that provides the full picture of how hydrodynamic separators function in the field. The second graph is a comparison of runoff volume calculations from this calculator versus the National Stormwater Calculator for both impervious and pervious areas, which compare favorably. In addition to providing instructions on how to use the calculator, the Instructions tab includes reference data, information on the calculated results, our recommended design methodology, as well as a design example. We also provide a comparison of the calculator's predictions against field-monitored data. The last 5 tabs are the engine of the calculator, including device and particle size distribution reference data, and calculations for hydrology, hydraulics, removal efficiency, and scour performance. Each sheet builds upon the prior sheets, pulling in reference data and prior calculations as necessary. The Devices tab provides some universal information, device-specific overviews and reference information, as well as all performance function formulas and variables. The PSD tab calculates and summarizes the particle size distribution information, including cumulative gradations used to plot results in the user interface, as well as incremental information used for calculations. In the Hydrology tab, impervious and pervious peak flows are calculated separately, then combined to determine accurate peak flows for performance calculations. Location-specific annual rainfall and project-specific runoff depths are also summarized for user reference. All equations, variables, and reference data used for runoff calculations are included, as well as historic precipitation data for 133 locations across the United States. The Hydraulics tab is used to calculate the water-related characteristics that affect performance calculations, such as high flow bypass volumes, water levels, and influent velocities. Finally, the Removal Efficiency and Scour tab pulls together all prior reference data and calculations to determine the device's overall performance. Pollutant loads are calculated and tallied for each precipitation depth and incremental particle size. All incremental calculations are then totaled, and final results are referenced in the Outputs section of the user interface. This concludes our overview of the treatment structure sizing calculator. Thank you for taking the time to familiarize yourself with this innovative and powerful design tool. And as always, we appreciate your interest in the Preserver.